there's an absolute 100% correspondence between the predictions of the non-expanding universe and observations of the images of galaxies. Absolute contradiction with the predictions of the Big Bang. And even though the Big Bangers who knew of these contradictions said, well, the galaxies were really small back then, so it compensates for the fact that they're not as large as we predict. Subsequent observations have shown that's physically impossible. There are independent measurements of the mass of galaxies that can be made two ways. Based on their luminosity, you can measure the amount of gas. And based on their velocity of rotation, which can be measured from their spectrum, you can use Newton's equations to measure their mass given their true linear radius. So the true linear radius in the Big Bang hypothesis is much smaller. You have these supermassive galaxies, galaxies as massive as our own, that are squeezed into 100 times smaller radius, 1,000,000 times smaller volume. But these observations completely cut through that because they show that the mass of gas is 10 or 20 or even 100 times bigger than the total mass of the galaxies if you use the Big Bang formula. And this contradiction completely disappears if you use the non-expanding formula. So you get what people call impossible galaxies. And another paper showed that these galaxies would be so dense, 100 million stars per cubic parsec. So that's 4 million stars per cubic light year, that the stars would undergo chain reaction collisions, that the collisions between two stars would create a cloud of plasma or gas that other stars would bump into and be destroyed, and the whole thing would blow up within, 100,000 years or something. It's impossible that the expanding universe predictions are right. They completely contradict by observation. So that's a third basic contradiction. The fourth one of my favorites, and as I say, this is not a complete list, is the large scale structures. The Big Bang, because the Big Bang happened, 13.8 or 14 billion years ago, there is a limit on the size of structures that could have been created in that time. And that limit can be checked observationally because we can see how fast matter is moving in the universe and how big objects are. And if you put those two together, even accounting for the expansion of the universe, you can get an ultimate size for objects. And that ultimate size, this is a prediction that hasn't changed essentially since the beginning of the Big Bang, is about 300 megaparsecs, or about 1 billion light years. So because things don't travel anywhere close to the speed of light, in 14 billion light years, you can only create objects 1 billion light years across. And now many astronomers looking at many different measurements, galaxies, phenomena called gamma ray bursts that we can see at great distances, quasars that we can see at great distances. All of these phenomena and many more outline structures that are much larger than this limit. Structures that are up to 4.5 billion parsecs. So that's about more than 10 billion, 12 billion light years in radius. So that completely contradicts by an order of magnitude the lifetime of the Big Bang universe. So these objects would have had to take not 14, but more than 140 or 150 billion years to form. And in fact, with reasonable hypotheses, they probably are a trillion or more years old. So these are things that there's just no way to get around. And of course, in a universe where gravity and plasma and electromagnetism are interacting in a universe that has no beginning, we have exactly predicted the hierarchy of structure up to these larger structures observed. And these weren't recent predictions. I have papers published back to the late 1980s that made these predictions that are completely confirmed.
Our videos come out of LPPFusion's research in fusion energy, which will power a future with abundance for all, with a clean, sustainable economy and environment. Goods, housing, and infrastructure would be extremely affordable once fusion kicks in. Fusion energy is the key to an advanced future. Support fusion research. The link's in the description. And thanks.
What do the big bangers try to do to rescue the observation of these large-scale structures?
They basically say they're flukes.
That's a hell of a fluke.
They basically say, it's like the man in the moon. People are used to seeing patterns. So
we're imagining them.
These big rings. I mean, if you've looked at the big ring or the big arc, these are, arcs of circles or a complete circle in the case of the big ring. The big ring is actually a nice little helix, just like we predicted. So they're basically saying, oh, you're doing the statistics wrong. These are just random fluctuations. So I should point out that this is also the reaction with the lithium. The latest reinforcement of the lithium, the big bangers were saying, well, somehow, we're not sure how, the stars were destroying the lithium, destroying them in just such a way to disguise that the lithium was much higher. But a recent discovery last year of lithium in the interstellar medium of our neighboring satellite galaxy, the Large Magellanic Cloud, showed that even in the interstellar gas, which should have exactly the Big Bang lithium, the lithium level is a factor of 4 beneath it. And what has been the reaction? Basically, that paper's been ignored. Now, I did see, I think it was yesterday, one paper describing this lithium problem, saying, oh, yeah, there was this observation last year. And they just basically said, well, yeah, there was that. But the other reaction they have to all of these things is they take them out of context and say, well, yeah, there's the helium problem. Oh, yeah, the lithium problem. We know about that. Oh, yeah, there's the large scale structure problem. Yeah, we know about that. Oh, yeah, there's the size problem. We know about that. But in each case, they take the problem separately and say, well, they're an anomaly. Overall, this is a very well confirmed theory. But if you put them all together, it's all whole. They actually have one valid prediction and at least a dozen, maybe you can, depending on how you count them, 16 or more contradictions. But if you try and put them together, I did this experiment. I did an overall, comparison of the two theories, expansion versus non-expansion, quite recently after the launch of the JWST. And I tried to get it published in monthly notices of the Royal Astronomical Society, which had published one of my papers dealing with the specific problem of the Tolman test. And after a little back and forth, an anonymous senior editor, not even an anonymous reviewer, said, if you want to publish an overall description of an overall comparison of expansion versus non-expansion, You certainly should, but it won't be in our magazine.
Wow.
Period.